Good evening, everyone, and welcome to another educational series from International Dermatology Education Foundation. Tonight, we have a very exciting topic, something totally different. Protexidine, a first-in-class technology. As you know, I am the president of International Dermatology Education Foundation, as well as a clinical professor of dermatology at Icahn School of Medicine at Mount Sinai and Indiana University School of Medicine. Also, I'm the medical director at my private practice and research center in Louisville, Kentucky. Our guests tonight are very special. A good friend of mine, Dr. Naiem Issa, who is a board-certified dermatologist as well as medical director of research and academic studies at Forefront Dermatology, and Steve Hernandez, who is the Senior Vice President, Research and Development at Topix. Before we go any further, I want to thank our supporter, Topix Pharmaceuticals, tonight, who made this program possible. Now, before we begin, if you're having any issues hearing the webinar, you can listen to the presentation using your telephone. Just select phone call in the audio pane and the dial-in information will be displayed. If you're having technical issues or if you would like to submit a question to our faculty, please submit your question in the questions pane on the right-hand side of your screen. At the end of this webinar, there is going to be a survey will pop up in your browser and will be emailed to you within 1 to 2 days. We would greatly appreciate if you could fill out this very short survey. Within also 1 to 2 days of this webinar, a certificate of attendance will be emailed to you. Also, again, if you have questions, please submit your questions using the questions pane on the right-hand side of your screen, and we'll try to answer all the questions as time permitted. Before we go any further, I want to tell you a little bit about my foundation. International Dermatology Education Foundation is a non-profit organization whose principal mission is to raise awareness and improve dermatologic care all over the world through education, especially in underserved areas. And through the pandemic, since the pandemic, I should say, we've been all over the world, including North America, South America, as well as Southeast Asia, Europe, and doing our broadcasts, as you can see some of the past programs here. Also, please stay up to date with us at Instagram, LinkedIn, as well as Facebook. So now, without any further ado, I'd like to bring back Dr. Naiem Issa and Steve Hernandez, and they're gonna tell us about this exciting technology, Protexidine, a first-in-class technology. Take it over, guys. Thank you.
Thank you. Thank you, Dr. Kircik.
All right. Good evening, everybody. My name is Naiem Issa. It's a pleasure to see everyone, and I would love to introduce to you Steve Hernandez, who is the SVP at Topix for Research and Development. And Steve, I'm just going to pass it over to you, actually, so that you can go ahead and give us our introduction here.
Sure. Thank you, Dr. Issa. It's been just really excellent working with you, and just so happy to get out and speak about this amazing new technology. This is the latest innovation coming out of Topix Pharmaceuticals. It is a proprietary molecule. We'll talk a little bit more about its roots coming out of the University of Minnesota Center for Drug Design. One of the most interesting things about it is that it has cosmetic applications that will show from some of our clinical studies the wonderful results that we get with it, as well as we're currently undergoing, and the subject of this speech tonight, this talk tonight, is going to be the amazing ongoing scientific research into future applications of the technology. These possible future applications show a lot of promise, and we really want to dig into the science and present it to you tonight.
Wonderful. Thanks, Steve. And pardon me for being in a hotel room doing this across the country here. So happy to be with all of you. And Steve, why don't you give us a little bit of background into the legacy of Topix and what kind of technology has emerged over the years, so that we can be more informed.
Sure. And I think if you, the slide will begin to develop as we talk about the technologies, but this is really our legacy. This is our background. This is what we were really first in and known for in the dermatology world. We like to fill in needs and interests. We speak a lot to the derm community. When they voice a need to us, we see what we could do in order to come up with products to support that and to really fill that gap. And the first, going way back, was glycolic acid. We were one of the first to, right going back to the original opportunities when the Eugene Van Scott patents were starting to expire, and even before that, looking at gaps between them where there was space to us first to come out with product, there was a need for high dose glycolic, and we realized there was a lot of irritation. Those who remember way back when, DuPont sent out a panic letter saying that it shouldn't be used on the skin because of impurities and liability. And we looked very deeply into that, and we realized that that irritation that was coming from the early glycolic acid was not from the glycolic acid itself, but it was from byproducts that were dangerous: methoxyacetic acid, formic acid, a known sensitizer. And we were the first to actually go to a pharmaceutical company, went to Europe, had to make pure glycolic acid that would be of a medical grade. In other words, it would be very similar to the specifications for lactic acid, which is a USPNF product. Lo and behold, when we did that, I got one of the best compliments of my career. I sent a medical advisor that we worked with 20% glycolic acid. He said, "Steve, I doubt that there's 20% in there." And I said, "Why would you say that?" And he said, "Because there's no redness or irritation." And that was proof right there that that redness and irritation was coming from the impurities and not from the glycolic acid itself. So that was a major first. We were able to do that, and that really formed our ethos moving forward, where we go, really, you hear the word medical grade bantered around a lot. It doesn't have a real official definition, but at Topix we defined it. We look at that word and we say it's a medical grade of a product, of a raw material, would be any material that the FDA would permit in a prescription drug. So we look at food grade, which is edible and very pure. We look at other types of purified grades for personal care, and those are the only types that we use. L-ascorbic acid, again, if you take a look at the original patents there, going back to Duke University, Sheldon Pinnell, you can look up their original patent at USPTO, and you can see they did amazing work, and they were awarded a US patent. We noticed, though, that the stability profile in DAR Pinnell 043, that patent, that when you look at it, it really had a limited amount of time. It went out just over 12 to 16 weeks or so. And what we did was said, well, let's do what we did with glycolic acid. Let's put a pharmaceutical definition on that. So the Topix patent for L-ascorbic acid product had 2 years of stability, where it retained a minimum of 90% of the original potency throughout that 2 years. And we were awarded the patent for that because we moved that date, stability date way out. So that was a real first for us. And then antioxidants. We were the first company to put antioxidants into sunscreens. That was a long time ago. I wish I would have patented that. But at the same time, now it's very common fare to see antioxidants in sunscreens. But we took it one step further, and we started to look at, there are thousands and thousands of antioxidants, but only very few of them will actually protect the biological system. And there's a landmark article in Methods in Enzymology that shows what it takes for an antioxidant, what specifically it needs to protect a biological system, which is a really fast reaction kinetics and the bonding properties of the molecule being able to absorb all that energy. And we introduced green tea polyphenols, which is, if you take your favorite antioxidant and go into whatever search engine you like, whether it's Medline, PubMed, NIH database, or or any of those, and you go in there and you look up that antioxidant and skin, what you're going to find out is that green tea polyphenols far and away have all the research. They're the object of interest to the medical community. A lot of cancer articles and things that come up there, but at the same time, we don't make cancer claims, but you could see, why methods in enzymology selected that group as effective, and you can see all the research grants and all the research being done in that class of molecule. So we focus on what is effective and what will be helpful to the derm community. Then delivery systems, we just awarded a patent not too long ago. We have other patents on delivery systems. If you can't get the active ingredient to where it belongs, and you can't do that in a stable and expedient manner, then the products won't work. And we've done that for retinol, and we've done it for a bunch of other things, and we've patented those delivery systems. So that's just an overview of some of the topics first, which preceded this new technology that we're going to talk about today.
So Steve, what I think most of our audience, if not all, and including myself, hadn't known is that there's been decades of work and research and trial and error to get these seemingly common, active ingredients into our hands, in a non-irritated way, something that can stay on the shelf for about 2 years. I think, what blew my mind as you were saying this is that for L-ascorbic acid specifically, there's hundreds and maybe even thousands of products containing L-ascorbic acid. And then the holy grail has been finding stability, right? And for you to master, the ability to have that for 2 years, some products I've used before, they turn colors, they turn quote unquote bad based on the color just about a month in, So that's pretty incredible for shelf life and for transport, et cetera. And then, for delivery systems, you can have the best ingredient, but if you can't disperse it properly or get it to where it needs to go, it's virtually useless. The same concepts as in, pharmaceutical chemistry, right? And so what we have here, ladies and gentlemen, is that we have a rich history of, research and development. And it's actually going to be great as we talk into next is something completely novel. We will say an ingredient that you may have never even heard of, but you may have heard the concept of over the last few years. So let's go ahead and jump into that and see what that's all about. All right. So Steve, I think what we'll do from here is that we'll talk about this molecule in a little bit, but let's set up the stage as to why is this molecule that we're going to talk about quite important, especially in our day-to-day for sun protection. All right. So let's go ahead and just jump right in and going into this first-in-class technology. So let's get into the nitty-gritty of some science of UV exposure. So everybody's really well aware, with sun protection and sun damage, and particularly ultraviolet light and the UV damage that happens, right? Ultraviolet light can penetrate to the skin. There's, UVA, UVB, and UVC. UVC is particularly blocked by the ozone, but we know we have an ozone problem, and we'll leave that at that. Then you have UVA and UVB that have their own distinct photochemical reactions that can lead to skin cancers. They can cause flaring of, there's photoallergic conditions, autoimmune conditions such as lupus, etc. But also very importantly is that you can have, skin aging too, right? Which is the holy grail for a lot of, endeavors. So what happens is that when you have ultraviolet light penetrating, right? Let's say it goes past your first defenses, which is your SPF, your barrier sunscreens and your chemical sunscreens. But once they pass through that first layer, they set off a bunch of chain reactions, right? And this is what causes your pro-oxidation state or your reactive oxygen species. And then they bombard the cells at various organelles, and then they have a chain reaction, keeps getting bigger and bigger and bigger, further damage to organelles, cells, and this wreak havoc, right? So essentially, we do want to protect, from ultraviolet rays, at step one, but also once they get through, you have this problematic chain reaction, and we should be doing something about that. And you can talk about antioxidants, as mentioned before, for like green tea polyphenols, but is there other things that we can do? So understanding that concept, I wanted to tell you all how I conceptualize sun protection, because I look at it as different buckets of what we can do to protect from the sun and the damage from the sun. So on the top left here, you see a box that says UVA and UVB filter. This is your sunscreen, right? These are your zinc and titanium oxide, right? And also you have your benzones, etc., that are your chemical sunscreens, and that's your first line of defense, right? that is sunscreen, right? And so you want to either bounce the rays off or absorb it, you know, and then make it less harmful. Part two is that also you can have iron oxide tint, and that is, in my view, different than just having UVA and UVB filter, and probably in agreement with what a lot of you think on this call right now. Because in the photomagnetic spectrum, we have a section called visible light, and that's why we call the rainbow, right? The Roy G. Biv part of the spectrum. Your UVA and UVB filters are not necessarily protecting against the visible light, and so here you can have, you know, photoaging, melasma, and hyperpigmentation. So by including an iron oxide tint of whatever sort, you can block that. So that's the top layer, right? But then what happens is that you do the best that you can, and you still have those rays penetrating through and causing those chain reactions. The reactive oxygen species, so on the bottom left there, you see antioxidants. And what do antioxidants do? They can scavenge the reactive oxygen species and help from further damage. Great, so we can incorporate that. But then, furthermore, you can have DNA direct damage, right? You can get these thymine dimers, which we'll get into in a moment here. And then what happens is that you are eliciting a repair response, and that could be, you know, with DNA repair enzymes. And this is really critical because with repair enzymes, right, you need them to come and get recruited, cut out those dimers, and then have the DNA reassemble so that you can replicate without causing mutations in the skin cancers, right? However, incorporating DNA repair enzymes is quite difficult. You may even read on the back of a lot of products out there that is like, oh, they have these repair enzymes from this thermophile of this marine species or whatever. But do you know how difficult it is to manufacture and to actually prove stability of these enzymes? That's a whole nother world where it's actually very difficult to manufacture and to have good stability for. Furthermore, you can have your add-ons as noted below, and these are your anti-aging ingredients such as retinol. People talk about exosomes, is all the rage these days, some growth factors, hyaluronic acid. You know, you have a stew that you can put together here. So, but to conceptualize, you have your filter, some sun still passes through, then you have your antioxidants, some repair enzymes, and then you can add some add-ons. So with this framework, then you can, you know, come up with the more ideal type of sun protection regimen. So going back to just the reactive oxygen species and antioxidants, the two major things that are current in existence are superoxide dismutase and catalase. These are two enzymes that all human beings and eukaryotes make, right? And what happens is that when you have ultraviolet irradiation, you have a reduction in superoxide dismutase and catalase. When you're taking away those workhorses, you have more oxidative stress, that you have more reactive oxygen species, etc. So what you can do is you can counteract this by increasing the expression of these proteins. You can increase the expression of proteins that protect those proteins, such as heat shock proteins, or you could develop, you know, mimetics or add the proteins exogenously. This is all, again, very difficult to do. You know, it's a large biological problem, and furthermore, again, these are enzymes. So to manufacture and place stable enzymes is quite a manufacturing feat, and it's not easy to do, and it's very costly. So there's an unmet need here for the antioxidant space. And then, as you can see, when you have these, you know, oxidative species, they can cause aging, wrinkles, you know, redness, you know, melasma, you name it. We won't spend much time here, but you understand the effect of reactive oxygen species and ultraviolet exposure. Then going back to this concept of thymine dimers. So when you have ultraviolet radiation, the thymines, which is the base pairs in your DNA, they get damaged and then they link up and they make what's called a thymine dimer. And this is what causes mutations, because what happens when your DNA tries to get replicated, you have that polymerase that comes and sits on there and tries to read it to make its complementary strand. It pauses there and kind of hiccups and it puts an improper base. Again, a concept that you already know here, but this concept is key. Now, specifically, once you go past the DNA, right, you also have ultraviolet A and B going, you know, deeper past the keratinocytes, and this is where you have, you know, issues with pigmentation, you know, aging effect on collagen and elastin, you name it. So this is multifactorial, and what if there was some technology to really help us to do all of that at once? And as you can imagine, I'm probably setting you up for bad technology tonight, right? So it's so important, guys. You know, sun exposure is critical now, especially with the ozone layer being depleted here. And what we have in our arsenal is not enough. And furthermore, erythema and redness is not a true marker or biomarker of what's going on at the cellular level and the DNA level. So just because you don't see red, like in the case of this unfortunate individual here, probably the worst sunburn I've ever seen in my life here. Just constant day-to-day UV exposure is causing damage, at the subcellular level. So keep that in mind. And you are making these CPDs, these dimers, right? They call these cyclobutane pyrimidine dimers, which is fancy schmancy for saying you're making thymine dimers, right? Like CPDs is what we put in the papers here, right? So we want to protect from these CPDs ultimately because they have the damage onto the DNA that can lead to skin cancer. Briefly, DNA repair, what happens is that when you have these dimer formations, you can have the accumulation of these or recruitment of DNA repair enzymes. And this is important because this is what happens in humans and eukaryotes. There is a different system, for a fun fact here is that different prokaryotes actually have the ability to make something called a photolyase, which is an enzyme that reacts to light and that can go and repair it on its own. So, but this is unique to humans and eukaryotes here. So ultimately, as we set the stage, is that there is a major unmet need in photoprotection for novel molecules that can reliably promote antioxidation and DNA repair, and to do this in the presence and absence of ultraviolet light. Is there such a thing? And there is. We'll cue in Protexidine, the molecule. Before going into the science of what the heck Protexidine even is, I would love to pay homage to the folks who actually created, designed this. And these are our colleagues over at the Center for Drug Design at the University of Minnesota. You can see their photos here in the bottom left. And I just want to, I hope that they're online hearing this, but I would love to give a great shout out to our inventors, Dr. Abbas Raza, who has been really doing the groundbreaking work, been working on this almost every day for the last 10, 15 years. Right? And so thank you for all of your hard work here. And then Dr. Robert Vince. So for those of you who are not familiar with Dr. Robert Vince, he is one of the world's most foremost intelligent medicinal chemists that I've ever met. And we'll see some of his work and what the brainchild behind this. And then Miss Christine Dries, also you'll find her in the publications as well. And so thank you for all of your hard work on Protexidine. But briefly, so Dr. Vince, so have you guys heard of abacavir before? In treating the retrovirus, HIV maybe. Well, he actually is the inventor. And you can see that we use this molecule for millions of patients day in and day out. That was his origin story. He also developed what is called the Vince lactam, which is incorporated in many antibiotics. And then furthermore, I think there are two molecules in the top middle and top right that you may be familiar. So these are acyclovir and valacyclovir, which we use for viral infections all throughout the world. So this Protexidine that we're going to talk about now comes from the brains of this group, right? So let's now go into Protexidine. What the heck is Protexidine even? And this is so elegant. So Protexidine is called acyclothymidine dinucleoside. Crazy Latin terms, who cares? Two thymines attached together. Now, ringing a bell, what we just saw on thymine dimers. This is critical because never before has we been able to produce, in the lab, thymine dimers in a way that is cheap to manufacture and stable once you have produced it in the lab to be able to put it in future formulations and to apply in different systems. So this is a critical milestone that took about 15 years to make. Also, for those who are wondering, why on earth would you make two thymine dimers, right? Or put two thymines together into a dimer and apply it on skin? Well, the most important concept here is that when you go back to the cell studies in those photos that I showed you before, there's that DNA repair, right? When you have repair, you have the excision of the dimers. The dimer in of itself is actually bioactive, and that causes all these sun protective effects that we're gonna look into next. So this is why this is a milestone. So what is the origin story of Protexidine? Well, as we just said, it's this thymine dimer that is stable. the group at University of Minnesota did a very elegant study where they had in a chamber, they had cellular DNA, right? And then they had another chamber where they included either control or Protexidine in of itself. And they shined some light to kind of mimic exposure to the sun like we, when we're out in the field here. What they found, and if we go actually just to show a more elegant photo here, these are the two different experimental setups, is that when you have the control, no Protexidine, the ultraviolet light passes through, and then you make your thymine dimer and you get some DNA damage. Very expected, right? It's a control. But when you had Protexidine, again, which is this thymine dimer, right? You do get DNA protection, because what is happening here, and in theory, based on this experiment, is that the thymine, that's attached to each other, then dimerizes, right? This exogenous, acyclothymidine dinucleoside, that acts as a decoy for the real deal, right? So if you have these thymines just circulating around, above your cells, they're shielding the DNA target, right? So that is pretty remarkable. And furthermore, there's evidence that they may enhance the repair enzyme activity, which we'll get into momentarily. All right. So, okay, you may say, well, we started off in the lab and we put it in a chamber. Chambers aren't humans. Okay, fair enough. But what if you put it on mice, on a mouse model? So here you have a mouse model called SKH1-E, where they made a formulation and put the Protexidine on the dorsal skin of mice and shined ultraviolet light. Furthermore, they also did it again in humans. Crazy, right? And they found a similar effect. When you have control and you shine ultraviolet light, you're going to make, as shown in the immunofluorescence, you're going to make those CPD dimers. But when you have Protexidine to block it, you're going to have a reduced expression of that immunofluorescence, showing less CPD formation. Here, they got a little fancy, and this paper is slated to come out in the next couple of weeks in the JDD. Protexidine was placed in multiple formulations, but 4 to be exact, and tested in the same experimental conditions on human abdominal skin explants. What this means is that for humans that have undergone, let's say, a tummy tuck at a local plastic surgery office, they have received those explants or tummy tuck, extra skin, and use them in the lab. And so in the lab, what happens is that you take these formulations and then you shine the light. Same deal, but now this is, again, as close to the real deal as possible. So they had control, which is shown on the left side of the figure here, and then 4 different formulations. What they found is that 4 hours after ultraviolet exposure, you have the most amount of CPD formation in the control group. You can see all of that immunofluorescence, all those dark spots. And then in the 4 formulations, you see less. And then 12 hours later, which is the time frame when you start seeing repair, right? You're having repair, those repair enzymes coming in and actually doing their thing. You find that 12 hours later, you still have a substantial amount of CPDs, but in those formulations, you find that there's minimal to almost none based on those images. So essentially what this is showing is that it's twofold. One is that Protexidine in these different formulations is causing a decoy type of response where you're protecting against the sun, right? And then furthermore, it could be accelerating that removal of CPDs at that 12-hour mark.
Yeah, that's very exciting to me as a chemist that formulates product, because it's one thing to see it in the raw material, but as Dr. Issa says, it's will it work in a human skin model in a finished product? And it took a lot of experimenting, but we were able to actually get these excellent results in the finished products themselves. So these are actual creams and lotions, sunscreens, and non-sunscreens that were made, moisturizers and products like that were made by our R&D research group with Protexidine.
Right, because typically, Steve, what we do is we put them in just a solution, right, in saline or DMSO or whatever, and we apply it and say, this is as close as we're going to get. But what we have here is from the University of Minnesota, is that they actually took these formulations, right, that could be cosmeceutical and directly applied out in the market, and found that there was quite an effect. to further hit it home, right? This is the same experiments, right? But here you have H&E or looking at histology to see that the damaged keratinocyte skin cells, right? Some of them, may turn into skin cancer, as we noted before. However, are you also able to get clearance of those damaged cells? And this is different from what we showed about removing CPD dimers from just the clearance of those dimers. Here we're talking about, can we cause selective apoptotic cell death of those that are at the point of no return? And indeed, you see that the formulations did have an increase at the 12-hour mark, the selective apoptosis that is basically clearing those cells away from the skin. And this is critical because this is a type of cellular clearance and cell death that is not necrotic. And so necrotic and pyroptosis are two different cellular death mechanisms where basically it's crash and burn. You have cells dying, and then you have necrosis, and then you have a field effect that you can get more necrosis, etc. Here you have Protexidine that is able to cause this apoptosis and clear those damaged cells so that you're potentially reducing the risk of having precancers and then cutaneous keratinocytic malignancies.
Yeah, that's a real important point. Thank you, Dr. Issa, because you don't get that massive upregulation of inflammatory cytokines that you would see with necrosis. So this is a very clean. It's really, your skin undergoes this natural cycle, and this apoptosis is exactly what you undergo every day as you turn over skin. It's very clean removal of the dead skin cell or the damaged skin cells. So thank you for that.
Absolutely. Then ultimately, can Protexidine cause the induction of DNA repair enzymes? And this data is not yet published, but we're hoping to get that out there for you to be able to read. But yes, there is evidence that on human skin ex vivo from these abdominal skin explants that we talked about before, that in one experiment you see at the top there that for the vehicle, right, there's no recruitment of the DNA repair enzymes, but the Protexidine itself, right, can cause the recruitment of DNA repair enzymes. So more to come on that, but that is, for me, probably the most fascinating data that we have on human skin at the moment. Don't you think, Steve?
Absolutely. It's just like you said earlier, it's really multifaceted. This is all ongoing research, as we search for future, potential applications for the molecule, but data indicates that there is just tremendous application, and just the excellent results that they're getting at University of Minnesota and that we're seeing independently at other laboratories is just amazingly encouraging.
Right, and I'll just put, kind of off the cuff here, is that, XPC, for our astute colleagues on the call here, XPC is a deficient enzyme in a condition called xeroderma pigmentosa, right? And so, as you know, these individuals have faulty repair enzymes, and so I'm just thinking out loud here. Maybe once we have more evidence, maybe these sort of patients could actually really have a great protective response because they are lacking this to begin with in their genome. Maybe we can actually get good repair enzymes to be recruited. So we'll see. So then, you may further want to ask, so, okay, this is all great data. The biology looks great. You're sniping some cells here. You're clearing some CPDs over there. But tell us what we all want to know. Is there any evidence on protecting against tumor formation? Now, the answer is, in my studies, yes. And this is the latest and greatest in terms of the in vivo biology. But we don't have any data yet in humans, right? But the current in vivo data shows that when you have ultraviolet light being shined with vehicle on the dorsum of these mice, right, versus those with Protexidine, what you find is that on that bottom graph here, red is the vehicle, black is the Protexidine. You find that overall, less of these keratinocyte skin cancers have developed in the Protexidine treated group. So overall, tumor burden is significantly less in those animals treated with Protexidine compared to vehicle. Furthermore, if you look at the top right panel here in C, you find that of tumors that are formed in both of these groups, those that are treated with Protexidine, which is the black bar, had generally more tumors that were less than 1 millimeter compared to vehicle, where the majority of the tumors were greater than 1 millimeter. So repeating this data, ultimately mice that were treated with Protexidine prior to ultraviolet exposure had less tumor burden up to 17 weeks past UV exposure, and in mouse weeks, that's a really long time. That translates to years in humans. Furthermore, if they had tumors, they were smaller in size compared to those treated with vehicle. And Steve, what do you think of this? Because to me, that is pretty darn remarkable.
It absolutely is. And for our audience out there, SSLs is solar simulated light, the same that's used in the SPF determination type studies, where they're measuring and putting known doses of UV to the skin. So I find this really amazing, and I really thank Dr. Issa for that point he made before, where that erythema is like a secondary endpoint. It's not a primary endpoint. So you can go out in the sun and not turn red and really believe that you're protected. You feel bulletproof, like, wow, I have this high SPF on, I'm out in the sun, not turning red, and you stay out in the sun. But little do you know is you might not be burning, not be turning red, but you're still forming the CPDs, which to me, in my estimation, are a truer marker of future or potential danger, or damage. So I think these types of studies are super important. And I really think that the way we think about how we protect ourselves is something that we really need to take a deeper look at.
Absolutely. Thanks for that, Steve. Then, so we talked about, potential tumorigenesis effect, in DNA, but what about, the anti-aging, potential for this and skin structure? So also the answer is yes, right? It does have an effect. So as you know, with the ultraviolet light, you can get your collagen, to be dismantled. So here on the left side, you see immunofluorescence looking at the skin explants, like we talked about before. That's pre-ultraviolet exposure. And then in the middle here, you see that that skin that is treated with ultraviolet light, but with vehicle is that you start to get that compromise of the basket weave structure. You can see those green, nice basket weave from the left starts to go into disarray, in the middle photo there. However, you also see that with Protexidine treated abdominal explant skin that was then treated with ultraviolet light, they actually had maintenance of that basket weave structure of collagen. Also, it causes some epidermal thickening. And here we have guinea pig skin, which is actually a standard in some of these assays. And what you find is that you see in the treated guinea pig dorsal skin is that the epidermis thickness is greater compared to untreated skin, as shown on the left there. And why does that actually matter? So part of your innate natural protective response to sun damage and ultraviolet light is that your own skin starts to get thicker. So if you look at some poikiloderma and some acanthosis in those sun-exposed area, that is the explanation, because ultraviolet light does cause a epidermal response. Here we're showing that there's this molecule, Protexidine, that's actually able to mimic that response and allow for some protection there.
It reminds me of the early glycolic acid HE stains, where they're showing that Gren zone volume increase and all of the activity that goes on in there with pro-collagen formation, ordering and bundling, and leading to new collagen formation. So very exciting when I see that change in volume there.
Right, and it's your own natural response in doing that. Here we have Protexidine harnessing your innate capability to do that. And then ultimately, if all this science sounds great, but is it actually safe? There's a ton of safety data. For those who want to read it, you can also ask the University of Minnesota and Steve, for that data. But essentially, they've tested the ultimate 5% cream formulation and they've tested it for corrosivity and irritation on dorsal skin. There's no inflammation there. Clinical and laboratory metrics. What happens is that you actually, in order to get that data, you actually pretty much bathe, the relevant animal model with this, formulation, and then you wait for a set number of days, and you try to see how much there is in the blood, and you also look at histologic changes of internal organs, and there's many organs that are looked at. And furthermore, they look at clinical lab metrics such as your typical, complete blood count panel, the metabolic panel, etc. So they found no histologic changes of internal organs, as well as normal laboratory parameters. And then would it ironically cause cancer? Well, the answer is no, because the mutagenicity studies and the genotoxicity studies all deemed it safe. So in summary, as we get to the final quarter of the hour, you have Protexidine, also known as acyclothymidine dinucleoside, which is a milestone in science and manufacturing, as well as medicinal chemistry, where our colleagues have been able to put together 2 thymine anucleosides and connect them together in a way that is stable, easy to produce, manufacturable, and safe to apply. And what happens is that when ultraviolet light from the sun hits Protexidine, it itself dimerizes to cause a number of beneficial effects. Protexidine, before it dimerizes, acts as a decoy dinucleoside to take that ultraviolet light away from the real deal, from your own cellular DNA, to protect your keratinocytes DNA, and then to start giving you UV mimetic effects. And then the dimerized form of Protexidine increases antioxidants. We didn't show some of that data here tonight because due to time restraints, but there's data actually in mice to show that you have increase in superoxide dismutase, as well as catalyzed production and the production of fibroblasts, as well as keratinocytes. So that's great for anti-aging. And then furthermore, we have some data showing the induction of DNA repair enzymes from that immunohistochemistry that we just showed. And furthermore, that you're getting faster accelerated release of those CPDs, right? The repair of those CPDs and selective apoptosis to reduce tumor burden. Here you have a photo of what a formulation of Protexidine looks around the periorbital area about 12 weeks after daily application. So you can see that the periorbital rhytids actually have improved, and you can see that there is lack of dyspigmentation around those areas compared to before. And in the formulation, which could be discussed at a later time, has a number of other active ingredients for the ultimate holistic OTC treatment.
Yeah, I find these as you go through these to be very, very interesting, because a lot of the earlier attempts at mitigating CPDs, one of the questions I got from physicians, as a scientist, people were asking me, well, if it really is active in that pathway, shutting down or preventing CPD productions, and it's a strong response, meaning a meaningful response that can really protect you, shouldn't the associated pathways, meaning shouldn't you see upregulation of selective apoptosis? Shouldn't you see, because of that you're clearing out the damaged cells, which sends a chemical message to make a brand new, perfect, healthy cell in its place, and that triggers a whole upregulation of free collagen and collagen formation? Shouldn't you see the wrinkle reduction? Shouldn't you see, why aren't with the earlier products, why don't you see those associated pathways triggered? And that's the real beauty of Protexidine, that we see those other pathways, or at least the data indicates that those other pathways are being treated. So we're actually, approaching the whole CPD issue in a meaningful way, and turning on everything that should be turned on when it's when you're properly working in that signaling grouping.
Right, and then the science bears that out, right? So you have clinical evidence as shown here in this example, as early as week 4, even after a daily application. You can see the discoloration getting better, as well as the forehead rhytids and wrinkles as well, and more so in week 12. So we have clinical, CPC, clinical pathologic correlation, but here we just have clinical histologic correlation between the science of Protexidine and what we actually see in the human skin. And also, you can see that there's some less redness in folks with the rosacea type skin, as shown here at week 12. And some endpoints at 12 weeks, you see that 100% showed improvement in fine lines and wrinkles, and 90% showed improvement in hyperpigmentation, and almost 90% showed improvement in their skin tone with daily application of Protexidine over 12 weeks. So to summarize, Protexidine prevents most CPD formation. It helps to repair and clear CPDs faster than with what we currently have. It prevents and clears damaged cells with that selective apoptosis function, and also helps to maintain collagen structure and density. And with that, Steve, I think that concludes our scientific portion of our presentation. Do we have any commentary before we move on to questions?
Well, I thank you, for your excellent presentation. It's so exciting to see the word getting out there, the message getting out there, and this is truly, just to me, this is data that is all pointing in the right direction. As I look forward to new possible applications for this amazing molecule, you see that the data is indicating that everything is lining up. Everything is lining up and pointing in the direction that we would expect it to, that we would postulate, and at the same time, we see the clinical proof. We see on the cosmetic effect, which is beautiful to see, but also we see repetitively that we're able to cover all of the different related effects that we see on the scientific side, on the ongoing research side. So we'll absolutely be continuing to fund this and really look forward to these future applications.
Outstanding. Well, thank you so much, everybody, for listening in. I think we're going to have Dr. Kircik come back online here. There he is.
Thank you, guys. That was quite amazing and eye-opening. And we have a bunch of questions. We have about 10 minutes. But Naiem, I think you still have the control. So can we go on to the next slide? And and then next slide here. Okay, I think everybody knows already about where to put the questions. Next slide. Nope. So I'd like to wait, go back. Okay, thank you for our supporter Topix. But before we go any further, we do have a lot of questions. So let me just line up the questions here, if you don't mind. So how many total animals treated? And then also, all the animal data is available.
That data, a lot of that is pilot study, and we haven't published, as Dr. Issa said earlier, we haven't published a lot of it. So as we release it into the public domain, it'll be more and more available. But right now we're beginning to publish, and as he said, in October or so, coming up soon, will be a big chunk of the data coming out in the first article, which will be in JDD. So more to come on that as we release more and more into the public domain.
How many total faces have been treated?
How many total faces have been treated?
Right.
Well, we had done in that clinical study, there was a total of 30. Okay. And then there were additional pilot studies that were done before that. So I'd say altogether be about 40 different, and then a lot of anecdotal, a lot done with dermatologists for opinion, things like that. So up over about 50 or 60 altogether.
What Topix product will contain Protexidine?
Well, as I said earlier, this is an amazing molecule that has cosmetic effects. So we're able to show data on the cosmetics. The purpose of this was to show the ongoing research into the future applications. That's what we did in this webinar. Talk about data that was pointing towards future applications. But for right now, we do have a cosmetic product that's available that contains Protexidine. We don't make any of these claims on it. However, it does contain Protexidine, and there are a lot of, there's a tremendous amount of data available at Protexidine.com. So if you go onto Protexidine.com, you'll see some clinical work, and you'll see a lot of cosmetic research that was done on it as well, and more information about that product.
So my curious friend, Dr. Gerald, wants to know, did all 30 have such amazing improvement?
No, there were varying improvements. As you see in some of the commercials where they say your results may vary, but what we did see across the board was that from the expert graders as well as from the people who were on the Protexidine product, they were very amazed at their skin. And one of the things in the change in the skin, one of the things that was not able to be easily captured on camera was the toning and lifting effect. And we had a lot of commentary coming back from the labs, how people kept touching their skin and showing how it was tighter and more toned. So that, and some of the expert graders described that as a collagen-rich appearance. In other words, they added a little bit of volume there. So as we move forward in new clinical research, we'll try and grade for that as well. But I can tell you that's one of the #1 things that people come back with is the way their skin feels tighter, healthier, and more toned.
Now, this is an important question. Would this be safe to use in pregnancy or patients who are breastfeeding?
We've put the product through all of the trials that are required for cosmetics, and there was nothing that would contraindicate that. However, we leave that always up to the physician and also to the patient. A lot of times I get a lot of calls about retinol, glycolic acid, things like that. And we always say, to them that if there's a hesitancy, then don't use it. That's not their market for that small period of time that they're pregnant or breastfeeding. If they're nervous or whatever, then no. And as far as we do the ongoing trials to go into pointing in the direction of drug development, on the drug side, they would say there are no rigorous controlled trials that have been executed in order to confirm, that type of use. However, all the cosmetic safety panels that are required for U.S. and we're also doing things, to get ready to sell overseas. All of those came back very, very favorable.
Now, at the end of the day, is this gonna be used as a sunscreen?
Let me answer that one. So going back to thinking of those layers of protection, right? What is sunscreen, right? So sunscreen is either bouncing off, right, or converting, the light to something else, right? For all intents and purposes. So it's a unique question because Protexidine in of itself, right? We saw all those after effects, right? But we didn't mention that it could actually be the decoy, right? And to shield the real deal. So at the moment you can conceptualize and say you can include it in sunscreens in its own right. However, maybe this poses an opportunity to redefine, what molecules can be considered sunscreens, because we talked about filters so far up till now with our regulatory agencies, right? However, Protexidine is so new and unique. I think that a reappraisal is in question.
So, Naiem, with your terms, CPD, fancy schmancy thymine dimers. The story, has been around for many years, and there are quite a few different products addressing those. What's so unique about the Protexidine? What's so special? Not to burst your balloon.
Right, absolutely. So for those who have been following this kind of literature for the last since the early 1990s, even, okay, you'll see this concept of these thymine dimers, being created and put into skin, etc., right? And so the thing is that it has been very difficult to manufacture, to produce, to make stable, etc. That was not figured out for almost more than 20 years, almost 30 years, I would even say, since the original work of Dr. Barbara Gilchrist, back in the day. And so now, our team here at University of Minnesota, and in collaboration with Steve, they've mastered it. So that's why there's no stable product on the market except this.
What's very, very important there is that a couple things. One is that the stability, we assay for it, we test for it. We're a drug company at heart, and we also produce, by definition, we're a drug company, but we also produce a lot of treatment cosmetics. And you can assay for this, and you can find it. People making claims on whatever enzyme it might be, whether it's photolyase or something like that, if you were to assay the product for it, first of all, you rarely see that enzyme showing up in the label ingredient statement. So it's not a direct claim. And then secondarily, if you would try to do a bioassay and find it, it's generally not detectable because it's not stable. Enzymes are not, if you look in the literature, look quickly on the internet, you'll find out that enzymes in aqueous solutions are very unstable. So while you might put them in at the time of manufacturing, they're not there later on. And for the most part, everything I've looked at, and that's why the excitement around Protexidine, we're able to trigger all of those peripheral pathways that are touching that CPD pathway that were never triggered before. So that's important. The other thing is just going back to the original research. This is a completely separate path. And it's a very elegant and a very well thought out pathway. So where in the past the attempts went for big chunks of very large molecules that are hard to penetrate the skin, University of Minnesota Center for Drug Design took it down to the essence, just the active portion, synthesizing that, making the decoy molecule, and then showing that it will form the dimer, protect you. Very elegant separate pathway, which is unique, and we're very thankful for.
So I think on that note, I thank you so much. This was quite amazing, and I thank Topix for supporting this program for tonight. I thank you very much. Naiem, if you don't mind, can you go to the next slide for me, please?
Sure.
And I'd like to invite everybody for our next webinar on August 20th, where Linda Steingold will be our guest, and she's going to discuss mild to moderate atopic dermatitis, burden of disease, and a topical pathway. I thank you so much. Good night, everyone.
Thank you. Thank you, Dr. Kircik. Thank you, Dr. Issa. Thank you to our audience.
Thank you.